Today we are going to discuss about the extrinsic semiconductor. So extrinsic semiconductor is also called the impure semiconductor. When we doped or when we added some impure atom to increase the conductivity of semiconductor are called extrinsic semiconductor. The semiconductor which is obtained after doping with suitable impurity atom to increase the conductivity of semiconductor is called extrinsic semiconductor. There are two types of extrinsic semiconductor. One is called N-type semiconductor and one is called P-type semiconductor. Before that, what is called doping? The process of deliberate addition of a desirable impurity to a pure semiconductor so as to increase its conductivity is called doping. Doping means the process of deliberate addition of desirable impurity to a pure semiconductor so as to increase its conductivity is called doping. The impurity atom added are called dopant, and the semiconductor doped with impurity atom are called extrinsic or doped semiconductor. So what should be the characteristics? What should be the characteristics of impurity atom? Number one, the size of the impure atom should be almost same as that of the semiconductor atom. And for this, the atom of third and fifth group of the periodic table are most suitable. So what is the first criteria of impure atom? The size of the dopant atom should be almost the same as that of the semiconductor atom. For this, the atom of third and fifth group of the periodic table are most suitable. Number two, the dopant atom should not destroy the crystal lattice. That means when we added this particular impure atom to the semiconductor crystal, its lattice structure should not change. So there are two types of impure atoms or dopant. One is called pentavalent and one is called trivalent. The pentavalent impure atom has 5 valence electrons in their outermost shell, and trivalent dopant atom has 3 valence electrons in their outermost shell. The pentavalent impurity atom are arsenic, antimony, phosphorus. Pentavalent impure atom are arsenic, antimony and phosphorus. And trivalent impure atoms are indium, boron and aluminium. Indium, boron and aluminium. Okay? So if we add pentavalent impurity atom to a pure semiconductor, the semiconductor so obtained is called N-type semiconductor. It is because the number of free electrons is more than the number of holes in this case. Have you seen it? This is the arsenic atom. It has 5 valence electrons. 1, 2, 3, 4 and this is the fifth. The 4 valence electrons out of 5 make 4 covalent bond with the 4 neighboring silicon atoms. These 5th valence electrons remain loosely bound with this arsenic. Therefore, by receiving a very small amount of energy, these electrons becomes free. Again, these electrons becomes free from this particular covalent bond. So therefore, how many electrons? There are 2 free electrons and 1 hole. There are 2 free electrons. There are 2 free electrons, 1 and 2, and 1 hole. So therefore, the number of charge carrier, therefore, number of charge carrier of electrons is more than number of charge carrier of hole. So since number of electrons is more, it is called n-type semiconductor. So what is the characteristics of impure atom? The energy level of impure atom is slightly below the conduction band. Energy level of these impure atoms are slightly below the lower value of the conduction band. This gap is very small, of the order of 0.01 electron volt. Therefore, electrons are easily jumped from this impure atom to the conduction band. Since this gap is very small, electron can easily jump from the impure atom to the conduction band. Therefore, number of electrons in conduction band, these are the electrons in conduction band. Number of electrons in conduction band is larger than the number of holes in the valence band. So these are the holes are in the valence band. That means these 3 holes are created due to jump of valence electron from valence band to conduction band. And other electrons are produced due to presence of impure atom. And this is called n-type of extrinsic semiconductor. Though the number of free electrons in conduction band is more than number of holes in valence band, this crystal is still electrically neutral. A crystal to etio electrically neutral. Why? Because this electron is extra for silicon atom. This electron is not extra for the arsenic. It is the required 5th electron. It is a required 5th valence electrons of arsenic. Though the number of free electrons is more, but this crystal is still electrically neutral because this excess electron is excess for silicon but not excess for arsenic. If this electron move away from this arsenic atom get positively charged. Okay? A semiconductor doped with pentavalent impurity is called n-type extrinsic semiconductor. The pentavalent impurity atom are called donors. Why donor? Because it can donate electrons to the host atom. The pentavalent impurity are called donors because they donate electron to the host crystal. Host crystals mean to the host silicon atoms or germanium atoms. In n-type extrinsic semiconductor, electrons are majority charge carrier and holes are the minority charge carrier. The semiconductor so formed is electrically neutral as the 5th impure electron is excess for semiconductor but not for pentavalent impurity atom because it contains only 5 valence electrons. And what is the energy? What is the energy of impure atom? The energy of impure atom is slightly below the lower value of the conduction band. It is of the order of 0.01 electron volt. Now p-type extrinsic semiconductor. P-type extrinsic semiconductor. A semiconductor obtained, an extrinsic semiconductor obtained after adding trivalent impurity is called p-type extrinsic semiconductor. যদি এটা সেমিকন্ডাক্টৰত আমি ট্ৰাইভেলেন্ট ইম্পিউৰিটি এড কৰোঁ, যিটো সেমিকন্ডাক্টৰ পাম তাক p-type extrinsic semiconductor. Impure atom বিলাক কি হ'ব? Indium, boron and aluminium. The trivalent impurity atom are called acceptor because they create holes which can accept electrons from nearby bond. In p-type extrinsic semiconductor, holes are the majority charge carriers and electrons are the minority charge carriers. In p-type extrinsic semiconductor, what happens? Number of holes in valence band is more than number of electrons in conduction band. An energy level of impurity atom is just above the valence band. Energy level of impurity atom is just above the valence band. As a result, electron jump very easily from valence band to impurity atom energy level, creating more hole in the valence band. Some electron may jump from valence band to conduction band. In my figure, 4 electrons are in the conduction band. These electrons are coming. These electrons comes to the conduction band after making the jump from valence band to conduction band, and the remaining holes are created when the electron jump from valence band to the impurity atom, energy level of the impurity atom. And what is the crystal? This is the aluminium, trivalent impurity aluminium. Aluminium has 3 valence electrons, 1, 2, 3. So therefore, these 3 valence electrons of aluminium participate in 3 covalent bonds of these 3 neighboring silicon atoms, but this silicon atom cannot complete its octet. Why? Because this side it has 2 valence electrons, this side 2, this side 2, 2, 4, 6, and this is 1, 7. In order to complete the octet, this silicon must have 8 valence electrons, but 1 electron, 1 vacancy is there. So this is called hole. Again one hole is created here. Again one hole is created here because one electron comes out of it. Eta electron here pora ulai goise. So how many holes are there? 1, 2. And how many electrons? 1. Since hole is the majority charge carrier, this crystal is called p-type semiconductor. Though it is p-type semiconductor, this crystal is still electrically neutral. Because this deficiency is only for this silicon atom. এই যে ডেফিসিয়েন্সিটোৰ কথা কৈছো এটো কাৰ কাৰণে হৈছে এই সিলিকন এটমটোৰ কাৰণে হৈছে this deficiency is not for aluminium because aluminium has only 3 valence electrons. If by some means this vacancy is filled up by an electron, this aluminium will get negatively charged because these electrons come very close to aluminium. Aluminium requires only 3 valence electrons to maintain its neutrality. এই অ্যালুমিনিয়ামটোক নিউট্ৰেলিটি মেইনটেইন কৰিবলৈ কেইটা ইলেক্ট্ৰন লাগে এটা দুটা তিনটা লাগে কিন্তু ইয়াত যদি এটা ইলেক্ট্ৰন আহি যায় তে অ্যালুমিনিয়ামে কি পাব এটা এক্সট্ৰা ইলেক্ট্ৰন পাব এজ এ ৰিজাল্ট অ্যালুমিনিয়াম উইল গেট নেগেটিভ চাৰ্জ. So what is p-type extrinsic semiconductor? The semiconductor obtained after doping trivalent impurity are called p-type extrinsic semiconductor. Here energy level of impure atom is just above the upper value of energy of valence band. তোমালোকে চোৱা এইটো বেন ডায়াগ্ৰাম বুলি কয়. ইন বেন ডায়াগ্ৰাম এনাৰ্জি অফ ইম্পিয়ৰ এটম ইজ জাষ্ট above the upper value of the conduction band. Since this gap is very small, electron can easily jump from valence band to the impure energy level, creating large number of hole creating large number of holes in the valence band. Some of the electron make jump from valence band to conduction band, creating equal number of hole electron pairs, creating equal number of electron hole pairs in conduction band and valence band. So number of holes in valence band is more than number of electrons in conduction band. Therefore, this type of crystal is called p-type extrinsic semiconductor.